It's a recording is in progress. Good afternoon, everyone. Now I welcome our expert, Professor Dr. Niranjan Swarup sir, Director General of Indian Society for Trenchless Technology, IND-STT. He is BTech in Civil Engineering from Regional Engineering College, Rourkela in 1987. He has been involved in various infrastructure development projects. The assignments handled by him have ranged from design, estimation, project planning, and execution. In addition to being a trenchless technologist, Professor Niranjan Swarup sir is also a formally trained arbitrator from Singapore International Arbitration Center and lead quality assessor from under ICQ project of European Council. He is currently the board member of various professional bodies like Engineering Council of India, ECI, International Council of Consultant, ICC, and the Council of for Application of Actuarial Science in Risk Management in Construction and Allied Industries, CARM. He also represents India on the board of several international organizations like Asian Forum, Asian Concrete Construction Institute, International Council of Consultants. He is nominated member of several consultative committees like Bureau of Indian Standards, BIS. He is the member secretary of several task forces and working group for different bodies. The prominent of them are the Jawaharlal Nehru National Urban Renewal Mission and National Council for Vocational Training. Professor Niranjan Swarup sir is one of the prominent trenchless technologists recognized internationally and invited to speak at most of the important international trenchless events world over. He has to his credit several trenchless publications. He is the editor of No Dig India Journal and regularly contributes articles in the international trade and technical journals. He has contributed substantially for the formation of code of practices for installation natural gas pipeline of BIS. In addition, he has developed code of practice for several trenchless techniques like directional drilling, horizontal earth boring, and pipe jacking. He has edited and authored several textbooks and training manuals related to construction and trenchless technology. He has been responsible for initiating several trenchless courses titled Surface Utility Manager, Trenchless Pipeline Manager, and post-diploma courses in trenchless technology. Additionally, he is now initiating several courses on SSEM, pipe bursting, and other trenchless subjects. He is also involved in establishing Trenchless Technology research and education centers across India. The first of one of them is now being initiated at Vidisha, Madhya Pradesh, titled National Habitat Center on Surface and Trenchless Technology under partial grant funding of AICTE. Recognizing his contribution to the trenchless construction industry, Singhania University accorded him the title of Doctor of Philosophy in the year 2012. Welcome to you, sir. Now over to you, sir. You may start the session. Thank you so much, sir.
Good afternoon. I work for underground construction and especially educating people and bringing the technology up. The subsurface construction is a business which basically helps in creating, maintaining and managing the utilities below the ground. Let me initiate my presentation. So we'll be talking about subsurface construction. Many of these topics or many of these ideas are something which we propose you to take up and start working, or rather create systems where our students are able to deliver the desired services to the industry. Now, this presentation talks about subsurface construction processes. What are we talking about? What are the applications of engineering in that? And then what could be done as a faculty member by us so that the boys and girls who are studying under us are able to create the infrastructure, a vital infrastructure for the society, for the urban areas, for the nation itself. You
Excuse
can
me, sir.
see the picture. Yes, yes.
Sir, can you make the presentation in the presentation mode so that
I made it.
it will be more visible? Visibility
Yeah,
will be there.
are you able to see or not?
Sir, it is not in presentation mode.
It's not in presentation mode. I converted that in presentation mode.
Yeah,
Sir,
please make in the present mode.
Sir, press
I
enter,
press F5.
please.
I
So
press
press
F5 and
F5.
I have done that, and on my screen it is like this.
Sir, but we cannot see in the presentation mode.
You are not able to see it in presentation mode.
Yes,
Yeah.
I think CIDC has to do it, sir.
Was that?
Yeah, CIDC screen is visible, sir, for us.
Yeah.
Okay. Your screen is not visible, sir. I think.
No, अभी तो मैं उससे exit कर गया. I have
Sir,
exited from.
sir, please share your screen, sir.
Beta, I have done that. I had done that actually.
Yes, sir. Please try again, sir.
Mm-hmm. Okay. Now you are seeing the presentation slide. See.
Not yet, sir.
No, sir.
Slide. Okay. I have to share it. Moment. Are we able to see the screen now?
No, sir.
No, sir.
No screen?
Yeah, now
Yes,
it
sir.
came.
Now it's visible, sir.
No. Okay. See, the thing is, I converted that into presentation mode, but looks like it's not transmitting the presentation mode thing on the Google. So I'm increasing the size of the screen. I hope now this is visible, right?
Yes, sir.
Surface visible? Okay. So the subsurface construction means any construction being done below the surface, ground surface. And what we are talking today is the faculty development program under ASLAP or क्या बोलते हैं? Oops. Just a sec. The new name has been Christian, and that is PARAKH. Is PARAKH. Anyway, so I'm Director General of Indian Society for Trenchless Technology, as Pratibha introduced me, and I also serve as the Director of Higher Education of Construction Industry Development Council. We work with different educational stakeholders like you people in enhancing the capacities and capabilities of faculty members as well as institutions so that we are able to train or teach more students into the real required technologies and techniques. Now, presentation, what we have has the basis, and the basis is underground space is the future of urban settlements. We need appropriate vision to preserve it for our future generations. This is what is something we require to have a primary understanding when we are talking about the underground construction or underground space. All of us are engineers, and as an engineer, whatever resources which is available to us, that needs to be protected. Whether I'm a civil engineer, whether I'm a chemical engineer, mechanical engineer, electronics engineer, whatever kind of engineer I might be. Underground space is something I use that at some juncture, or my systems are used to create and maintain and manage few things in underground situations. And we need to be aware of what is required and what is to be done. The presentation has 6 sections: background, subsurface construction, trenchless technology, geoengineering considerations in the optimum use of underground space, city-specific subsurface utilities vision document, and then finally concluding remarks. I would be making propositions to you that please do this so that we are able to cultivate the capacities and capabilities in our industry, in our professionals, and our users. So let's start with the background. Trenchless technology is the family of subsurface construction techniques that help in remotely constructing, maintaining, or replacing subsurface utilities buried below the ground surface without excavating a continuous trench. In the national context, trenchless techniques have an extremely important role, both during construction as well as later during operations, maintenance, and replacement at the end of the economic life. As the urban area managers, it becomes imperative for the engineers to have sufficient internal capability for construction, operations, maintenance, replacement of buried utilities, both conventionally as well as through trenchless methods. And as faculty members or as teachers, our business is to see to it that they are able to deliver all that. Through this capacity, the nation would be able to get subsurface utility developed and managed efficiently and effectively. Prerequisite to achieve this capacity is to have proper vision for the application of trenchless technology in the development, maintenance, management of subsurface utilities. As post-construction management and maintenance of buried utilities through conventional modes may be challenging and impossible in certain situations. Whatever we do, let's say I'm talking about electronics, I'm talking about GIS, I'm talking about positioning systems, I'm talking about remote operations at a later date. Now, if I'm using even RFID is used extensively in these systems. If I'm using that, I need to create a situation which gives me the best possible result from my efforts. In this talk, we shall be looking at different aspects of subsurface construction and such vision attributes and modes to create such vision documents and put them in use in nation building. My idea is that each of you is teaching engineering students in different cities. Create a program where your students, whatever branch they may be of, work in creating these documents, and once they are able to create these documents, obviously they would have better understanding of the needs and requirements of the basic industrial systems. And that is what is the objective of PARAKH as well. Now, coming to the second section, which is subsurface construction, just let us look at the need and logic. Why do we go for subsurface space? I use it for location and land use pressures because urban areas are completely loaded and utilities and other structures. The more we put them below the ground, the more space I have for the usage of other things which can be only used above the ground. There is environmental protection, preservation requirement. I need to isolate my structures or isolate my habitat or isolate my land mass I am forced by topography. The topography could be something like, let's say, you're talking about cities like Madurai. In Madurai, part of the city is on hill, part of the city is on flat. So that topography defines this kind of usage. Haridwar or Dehradun, these are the cities where the topography plays a major role. Then there are barriers which have to be crossed. There would be a rivulet, there would be a man-made structure like a railway track, a bridge, or anything, and you need to go across it. And all these things require usage of underground space. You can do it conventionally, or you can do it through Trenchless technology. Now, what are the advantages if we talk about? It will be time saving, reducing the flow of the private vehicular traffic, reducing the surface land consumption, more space for pedestrian and users. Urban development issues are handled in a better way. Like for an example, we are constructing 100 smart cities today. All those smart cities require more surface area, and that more surface area is created by clearing of the utilities which were lying very close to surface or above surface. They are being put below the ground. And how are you doing it? We are doing it through application of conventional as well as trenchless. And most of the cases, when we are talking about smart cities, it is the trenchless which is being used. Energy savings uh, through mass transit, reduction in external costs like noise, pollution, congestion, accidents, all those things can be avoided if everything goes below the ground and you don't have any hindrance above the ground surface. Now, how do we do it? We do it conventionally, that means we are excavating the soil, placing our structures, and then covering it. This means surface is disrupted, the adjacent structures are damaged, the cost and duration of work related to above ground construction goes up like anything. We increase, the more deep we go, the mechanization has to be increased, your protection has to be increased, and all those things make the conventional construction methods more difficult. Cut and cover method versus bolt tunneling and trenchless method naturally are the future. And believe you me, the boys and girls whom you are teaching, they require this kind of basic understanding. And through this talk, I'm trying to cultivate that particular capability within the faculty members of various engineering colleges. I hope you will be working with me, and not today only. It's just beginning of our discussion. We will go in future and we will work together. Generally, when we are talking about cut and cover, these are the problems. The underground space in public right of way is heavily used because the cities what we have are pretty old, and old cities would have buried utilities existing there, and then we have to create another utility, another utility. The more we develop the urban areas, if a settlement had, let's say, 20,000 people, and we were supplying water at the rate of maybe 100 liters per head per day or 70 liters per head per day, there was a quantum of water which was coming in and the quantum of water which was going out. Next, we construct 10 times larger settlement in the same land, on the same land, just because we are going up. We make higher residential structures. What would happen? The water supply demand, the drainage demands will multiply accordingly. And believe you me, your urban space in which you are draining all these or supplying water from these are totally saturated. And if that is there, there will be challenges. Traffic congestion is also growing. You look at any city, most of the cities are having immense traffic jams and the roads are congested. And on top of it, when you are creating a public utility, you cannot go and create that in any individual's house or individual's land. It has to be created within the right of way, which is generally a public land. So that basically means the moment you are having the traffic moving on that surface, you cannot do the cut and cover or open cut conventional excavation. Street pavement damages do occur when you are kind of opening up and placing your utilities. Surface restoration cost goes up every time, and direct and indirect business losses where these excavations and these cut and cover are being done. They incur these losses. And whether they like it or not, whether they say it or not, it is actually a loss of the community, and that needs to be prevented. After creating the utilities, What then? This is a picture of Arvindo Road, Arvindo Marg in New Delhi, and which is very close to All India Institute of Medical Sciences. And you can easily visualize the situation. Here, the road caved in because of the rainwater, and it's not an isolated case. It's happening across the nation. Many places, the pipelines are old, they are fragile. The load is there. Because of the load, the pipelines crack. When they crack, the fluid being or solid being transported within them or within those leaks out, moistens the soil around the pipe, and then because of the pressure, the soil gets inside the pipe and there is a cavity created, and that cavity in turn leads to road cave-ins. Do we want that? Or do we want this? This is a picture from, I believe, I think Hyderabad. And you can see, and this is a picture, I think, from Chennai. Or this is a very, very common feature in many of the older cities where the drainage lines have completely choked and the fluid is flowing in the surcharge area. Surcharge means when you are having a pipeline, the lower section is considered to be the section where the solid or the fluid has to flow, and the upper section is kept free so that gases can move on, and that section is called surcharge region. Today, even the surcharge region are being utilized for the flow of the liquid, and naturally this is going to happen. Or we are laying CNG pipe, PNG pipes right, left and center. In so many cities, we have been planning and executing pipeline projects. What happens when somebody goes and accidentally damages one pipe? Naturally, this is a possible accident or result. Now, the failure which I indicated, this is a schematic movement on that. First, you have the soil or other materials flowing in, then you will have the soil voids created, and the moment soil voids are created, vehicular traffic itself will be able to crush and crack everything, and the pipelines will collapse. And once this happens, the pipelines actually become worthless, and you need to spend so much money to rectify them. So please decide, do we want our subsurface infrastructure built to last, or we continue repairing them? As an engineer, we need to see to it that if I'm building my infrastructure for a defined age, maybe 60 years, maybe 20 years, it should survive for 20 years or 60 years, whatever is the design life. And to get that, it has to perform, it has to be created in a proper engineering-like manner. And who does that? My students who are going out and working. And who assists them? You and me. We tell them this has to be done, and this is how you do it. So, what is the option available? Conventional methods still will be there, but Trenchless technology is the latest option available to them. Trenchless technology is defined as a set of techniques for remote installation, rehabilitation, and repair of utilities, pipelines, and small tunnels, linked by their lack of need for digging a continuous trench for the installation of new structures and their repairs. So generally what you have is micro-tunneling, directional drilling, rehabilitation, replacement, all these things happening under this, line of operation. And believe you me, all these require different proficiencies, not only civil engineering, they also require proficiencies in many of the engineering branches. And that is why we are trying to sensitize and bring you to the thought that everybody is needed when we are talking about subsurface construction. If I'm looking, if I go to the definition, basically what we are doing is we are creating utilities below the ground, we are replacing utilities which were created earlier, or we are rehabilitating them. And since we are doing the job without excavating continuous trenches, I would not know what is happening below the ground or what is buried below the ground. So I need some special or specific type of service. So all these four segments comprise this Trenchless technology field, and we need to educate our students that they must be able to apply the understanding, their engineering knowledge and understanding, and create a state-of-art system for these kind of works. When I'm talking about geoinstallation technique, being created remotely, my interest is to create a cavity. Now, how do I create the cavity? I can excavate the cavity, I can shift the cavity sideways, or I can pump in fluid, and that fluid dissolves the soil, and a cavity is created. And because of the pressure of the fluid, the soil will come out. Now, each of these methods or each of these processes form a part of trenchless technology for new installation. And believe you me, all these things are done not only by civil engineers, but electronic engineers. You have to do RF signaling, you have to do transmit the inputs and outputs from your machine for real-time decisions when these cavities are created. And obviously, all that is needed, all that needs the engineers to be sensitized or knowledgeable in different fields of engineering. Then comes replacement. Under remote control, what I'm doing is I'm kind of removing the existing pipe and placing a new pipe. The above ground remains undisturbed. Now, this particular thing is called replacement. And how do I do it? I can burst the corroded pipeline from inside, like inserting a cone and then enhancing and splitting it. Or I can pass through a knife can split, and the pipe or the structure can be cut. Or I can implode the corroded pipeline by certain equipment, by which this equipment goes in and a tunnel is created, and all the existing pipes, they are crushed and taken inside this machine and then brought out. Again, as I said, for new installation, here also you require many competencies in different branches of engineering. Replacement techniques use these three lines of replacement mechanism basically. Then comes rehabilitation technique. Rehabilitation means if a pipeline is malperforming, it is not able to deliver its duty. There are four general duties: structural duty, environmental duty, its operational duty, and hydraulic duty. So these four duties, if a pipeline is able to perform, nice. But if the duties are being performed on a on a lesser, the deliverance is lower or less, you need to bring that back. And how do you bring that back? Let's say if I'm talking about hydraulic duty. Hydraulic duty means whatever fluid which is being put in, same amount of fluid has to come out. If the same amount of fluid is not coming out, that means the fluid is leaking out of the structure. The structural duty, that means the load which is coming must not compress or damage the existing pipe. The environmental duty, that is, you are sending in one level of polluted material, and the fluid which is coming out has a higher pollution levels. So it should not happen. And the fourth one was operational, where you are supplying X million liters of fluid, and the pipelines are not able to transmit that flow rate because of their constraints and other things. All these needs to be removed, and that removal is either done by plugging the leaks, inserting membranes so that the leak, only the fluid going out is stopped, or we insert a load-bearing pipeline which can take the load so that the failure does not occur. So all these three methods come under rehabilitation techniques. Then comes subsurface survey. Under remote controlled operations, subsurface information is gathered by either subsurface utility engineering processes, which has a basic protocol. How do you find the methods? And then you conduct the geophysical investigation programs or pipeline condition assessment methods. There are methods like ground penetrating radars. There are methods like pipe and cable locators. There are methods like vacuum excavation. All those things enable you to know what is buried below the ground as best as possible. The knowledge has to be as best as possible. And that application or that result tells you where to do your job on trenchless methods and where to avoid. Or if you have to go for something you have to take precautionary measures that, okay, fine, you don't have any other choice. Then you expose those utilities or structures and install your pipeline accordingly. So all that things are done through these three broad groups. The application of trenchless techniques must be done on the basis of साहब एक लेक्चर दे रहा था, मैं बात करता हूँ आपसे जी. So from these three method groups, individually or in combinations. So these are the primary four fields of trenchless technology application or subsurface construction methodology applications. Now, what are the implications of trenchless technology? I told you about the negativity of conventional construction. Implications are that costs are independent of depth. The deeper you go, the costs almost remain same. Whereas in open cut, the costs, the more deeper you go, the cost naturally goes up extensively. Utilities will occupy larger zones of underground, and then if you require to lay something, you've already filled up the upper reaches, you'll have to go below them. A standard process in urban development is that once initially this city is created, you will be developing utilities at one level. Then comes the later part when the city is growing. You might be developing the utilities below them, then below them, then below them. And the younger the settlement, deeper the utility would be. So they are going to increase, and trenchless technology helps you to achieve that without much damages to the existing infrastructure. Interference with future large-scale underground structures, naturally, as I indicated. Then comes social cost. If you are excavating somebody's frontage, the road is being excavated, and he has a shop or a business there. Obviously, his business is spoiled, and that is a social cost which the society pays for your project. This social cost can be contained to a large extent if we are able to do it through trenchless technology. Then there are utility systems could be changed to accommodate new methods by using trenchless technology. Like let's say you laid a pipeline which was having some diameter. Now you came back and you want to increase the diameter. Your choice is that lay another pipeline besides that, or you use some trenchless method to use the same right of way and place another utility there. Doing that will be more beneficial. So all these are the implications of trenchless technology. Now comes subsurface construction and trenchless. Trenchless technology applications are remotely operated, smart construction processes that are extremely useful for creating, maintaining, and managing subsurface utilities without continuous excavations as we defined. Through this feature, surface and subsurface infrastructure destructions in urban areas can be avoided during construction. In addition, positioning processes and systems of these utilities help in creating correct as-built database of buried utilities, providing valuable inputs for future maintenance works of subsurface utilities. Take for an example the smart cities. In smart city, the objectives, there are 4 core objectives, and out of those 4 core objectives, 3 objectives are linked to the buried utilities and their perfect performance. If they don't perform properly, naturally, the smart city will not be able to render the services for which it is being designed. The monies are being invested. Like say the drainage, if your utilities are not able to drain the exact amount of precipitation or water collected or water drainage or whatever, that would mean that inundation would take place, flooding will take place, and the structures could get damaged or there could be a loss. Now your smart city will be operational or functioning only when your buried utilities are properly known, and if there is any error or there is any problem, that is also known and that can be rectified in due time. All that is possible if you are doing trenchless technology applications. Now, let's go to the engineering of underground space. So, the primary thing is that we need to optimize the underground space usage. If I have some underground space given to me by my forefathers, I need to transfer that subsurface space to my descendants so that they also get a proper underground space which they can also utilize. So basically, it is the need of community which have to be met. We need to maximize the benefits of underground as developable space. Like take for an example, if you have a city situated close to a river, your drainage levels will be defined. And in case if you are going with that philosophy of constructing new pipes below the old pipes, there is bound to be a situation when your new pipes will be lower than many of the drainage or drain out locations. And if that is happening, either you are pumping it out or you are not able to really evacuate the sewage. So you need to maximize the benefit that such kind of situations are completely avoided. Reinforce positive features of the surface environment so that they are properly livable. Effective use of geological settings. I must construct or develop my structures so that geologically, whatever is the soil available or whatever is the ground strata available, I use that. So plan and design for future use and sustainability. So this must be our basic objective, whatever we are doing. Now, if I look at the utility life cycle, it comprises of 5 phases: planning and design, construction, inspection and maintenance, rehabilitation and renewal, replacement or removal. When I'm talking about planning and design, is basically I plan the route, I do the site investigation, I visualize the site model, I design for construction and design for life cycle. It is not that you only design for the, you design the structures for their health. You also have to see to it that how long your structure has to perform. And that basically means you're designing the complete system rather than a single component. Then I go for construction. So I conduct the construction processes, and in that scenario or in that position, we upgrade the site model because whatever we might have assumed, whatever my survey data or my subsurface utility data would have shown to me, there could be some difference from the real situation at the site. So we upgrade the site model so that we avoid the damages, and then we create the construction records that this is how we made. Now this is a very, very important part of the this life cycle, because these construction records, when used properly or when documented properly, can tell you when your system is going to fail. Say for example, some place you constructed some pipelines with some material, use some kind of joining items, and some kind of loading is there, which could be the vehicular traffic moving in one direction, water tables, level, and all those things. Now, everything, even you run it on a probabilistic models, which are available now, Markov chain and other evaluators. So you would know that these are the probability of failures of a particular location. If the probability of failure is known, obviously the rehabilitation and replacement can be planned. So basically that means you will be managing your data. So data management would be the next step. You would use low cost sensor like RFID sensors placed with the pipelines. You would have settlement sensors where you can know the ground is going down or not. Then you use smart materials which can heal themselves or at least inform you that this is a problem coming in. And then ultimately you go for performance feedback. The performance of your structure is being reported and recorded. So that helps in your correcting the construction records which you created in the previous step of the life cycle. Now, this would tell you when your pipeline is going to fail, what is the deterioration process and what is the possibilities. So you can predict the deterioration, manage your asset accordingly. If the moment you manage it, your deterioration process gets postponed. Like let's say if you have a structure where you have a timeline, if you're plotting the life expectancy. So if you're talking on x-axis, the life timeline and life expectancy on this line. your movement will be coming down, and if you do some rehabilitation, it will go up, come down, go up, come down. This way, you'll be able to enhance a better life cycle or better delivery from your system. So you manage your asset, and to manage the asset, you will be selecting the methods which are more applicable, rehabilitation methods or replacement methods or a combination thereof. And then finally, when you do that, obviously this curve which I just showed you by hand, this needs to be updated so that the next cycle or next activity is also contained. Then comes replacement and removal. When your utility is finally unable to deliver the services, like say your pipeline has cracked, settled down, and after a major settlement has taken place, it is almost impossible to rectify that. That is the stage when you have to manage it. And believe you me, at that time, most of the people who really constructed that utility might not be available. So you have to locate the utility. Again, you go to pipeline condition assessment and subsurface utility engineering, design for the replacement, and update the records. So this is what is the complete utility life cycle. And as an engineer, this should be in my mind. And if my student is going in, whatever business he is doing, if he is a chemical engineer, he would be talking about slurries, he would be talking about polymers, he would be talking about anything which swells, expands, or contracts depending on the needs. If my student is a computer engineer or IT engineer, his role would be maybe in the utility data management, because believe you me, in a city like Delhi, we have not less than some 10,000 kilometers of pipeline buried below the ground, if we measure all, line to line. And data management of that is something which is a huge job. And obviously, the person who has to go and do the data management is someone who has to be educated about the whole system. I can't just teach him how to code. In addition to coding, he also has to know what is utility life and what are the attributes. So all that comes under utility life cycle, and this is where mine and your role enhances. So, how do you engineer the things? The process steps are: define the needs, generate alternative solutions, evaluate alternatives and select the most suitable solution, conduct the detailed design, promote the design so that it is accepted, construct and test, performance evaluation is done, and then conclusion reporting is done so that the database is created and you work on subsequent things, or you can use the same data for your proactive utility management or proactive management activities. Obviously, all this requires deep engineering understanding. When I'm talking about geotechnique, see, constructing something, some structure above the ground is predictable in nature because you would know what is happening above the ground. But below the ground, the unpredictability will be there. There are uncertainties, the conditions change. You may see a ground surface going flat, but the subsurface might be undulating or maybe having a sudden drop, sudden rise, whatever. Appropriate expertise and timings are required to handle it. And then comes when you are working below the ground, the contract documents are created when the plan is made or the theoretical model is created. Now that contract document has to define what happens if this kind of problem comes in. So obviously a contractual sharing of risk is needed when we are talking about geotechnical. And then when you are conducting any investigation, that basically means you are going for blood test, you are going for urine test. That test or report will not tell exactly what is the sickness. It will just tell how much away you are from the standard normal values. And that variation gives a profile that this is what is the sickness of a person. Now, when we talk about geotechnical investigation, the thing is the result which comes out does not help you in the does not give you any saving, direct physical money return. No, but it saves you in different activities when you are doing the works below the ground. So all those need to be understood and cultivated in my engineers. May that be subsurface utility engineering, where we are drawing the buried maps by conducting the 4 stages of subsurface utility investigations, or we are doing the geophysical investigations, we are kind of doing the excavation, we are doing the auger boring, we are doing the boreholes, all those things have to be used. Now comes in trenchless technology, these are the issues. They are more remote operation. Right now, there are contracts in northeast of India, which are about 4 kilometers of drilling. You can imagine when you are drilling something, you have a prime mover. There is a drill head which is placed in the front of it, and then there is a drill rod. Now, this drill rod is rotated by the prime mover, and the drill head cuts. Imagine that going for 4 kilometers. Imagine holding a bamboo in your hand and understand what kind of flexure is going to come. So this is something which makes the whole operation quite challenging. You need to understand many issues which have to be done by the students. And obviously, if you have the basic understanding with you, you can talk about how bentonite is made, or how bentonite is used to give some kind of support to the excavated soil, how you are putting your RFID tags, how you are doing the GIS mapping or as-built drawing mapping, all those things have to be understood. There is fact of life that you are not able to see the exactly what is in front of your excavation or in front of your old pipeline. So obviously it would be interpretation, and the people who are working in the sector needs to cultivate that kind of understanding. The life cycle approach to the design and management of underground structure is therefore more important, because if you construct it today and it fails 10 years later, whereas you wanted the whole system to survive for 60 years, your whole effort is wasted, and not only your whole effort, whole system might be wasted, because the other sections, even if they have longer life, they will not be able to perform this portion has performed. I was invited to some project in one of the JNNU RM cities. It had close to about 265 kilometers of trunk sewers to be constructed. Only 11 kilometers of that portion came under hard rock, which was almost impossible to excavate. The contractors built the remaining lengths, charged the money to the JNNU RM city owners, but the lines were not workable. Why? Because this section did not have, could not be connected. And if you don't connect the whole section, the city cannot perform. So all that needs to be seen, and how do we work it out? And here comes the greater use of seahead technologies, like I discussed about the SUE, GPR, pipeline, or cable locators, and all those things. They have a greater use. And obviously, as teachers, we need to sensitize our students that, look here, this method helps you to go ahead and see the things. Like in see ahead, you have GIS, GPS communication, you have computational analysis, which gives you the real-time soil characterization and underground image processing and all. All these, this chart I'm not reading, this will be available to you through the through our organizer. They will send it to you. So this is one set of seahead technology. There's another one where you have the sensor and data technologies, where you have the sensors moving inside the existing pipelines and the data is collected. All this, believe you me, require different competencies in different fields. Now, what are the future trends what we are looking at? If you see, urban flooding is becoming a major menace in many of the cities. Wherever we have coastal cities, wherever we have cities on mountains, urban flooding is extensively, even in the flats, the urban flooding is happening. We need to have our engineers who can provide solutions to overcome those urban floodings, or reduce those frequencies to the lowest and volumes to the least. The operation and maintenance of existing infrastructure assets. I don't know if this has been raised in ASLAP or not, or this program or not, but for the last 10 years, every year we are building about 4 lakh crore rupees, not only last 10 years, it's about 25 years. We have been building infrastructure which is about 4 lakh crore rupees per year. So we have invested close to about 100 lakh crore rupees of the nation's money in different infrastructures. Where deterioration is taking place and we need to operate and maintain them. If we don't, that money is going to go to waste. It will be wasted. The bridges, the roads, the highways, they will be performing very badly. And as far as bridges are concerned, they pose a greater challenge because they can collapse, they can fail. Yeah, and if they collapse, it's a major loss for the society. Then comes smart city utility operations and management. We are building 100 smart cities. Obviously, I need my boys and girls aware that this has to be done. And this basically he has to know that this is my life cycle, utility life cycle, and this is what I have to see to it. Say your boys, when they graduate, they go and join a job where the smart city is already operational. So from the user point of view, he has to start working, and that basically means he has to know the things which have been done before him. And then accordingly, he has to take some call on the proper process. This is what is one of the major future trends what we are facing. We are going to see. City gas distribution networks. Obviously, most of the cities, we are building natural gas pipeline networks, and the last mile connectivity, where the main trunks are going. Beyond the main trunks, there are lines which are going inside the houses, they are going inside the society high rises, that need to be properly operated, maintained, and damages prevented. Because if you don't do it, you can see that fire color. And I am sure nobody loves it. Enhance subsurface utility networks, cater the rising urban demand. Most of the places, what we are seeing today is that the rural populace is migrating to the urban areas due to better quality of life being offered in urban centers. And once they are moving in, obviously the demands are rising, and those demands have to be catered. Obviously, we require engineers in different fields. Major transportation and major transport tunnels are being made today, and like a Jojila Pass tunnel, which has gone to 5 kilometers. Now this is going to help in reducing the travel time in Jojila Pass and also assist people to travel in the winters when it was almost impossible. So all those things are coming, and obviously they provide opportunity to us. On international demand side, the better infrastructure for cities, improvement and extension in more developed countries, and basic systems still needed in less developed countries. Many of my students have been traveling globally. They go out of India, get engagement, employment, contracts in different nations, and they find a very good livelihood. I would hope, or I would wish, that most of your students, most of you should have such kind of students who, upon graduating, are capable to go abroad, go to many more places, and earn money for themselves and for the nation. What is going to be the impact of engineering professions? There's not only one, it's all the professions. Increased market for underground construction, increased imperative for professionals to be more involved in underground space use issues, new geo-related research technology, development opportunities. These are some of the possibilities which I can propose that you can think about conducting researches, you can think about having underground space usage, creating such kind of professionals, and obviously the underground construction market is growing. Then comes city-specific subsurface utilities vision document, and this is something which I'm proposing to you because I believe that all of you are based at different locations across the nation, and in your city, the urban authorities or civic utilities which are rendering these services require such kind of support. Today, they don't have access to the major engineering colleges on the state capital or on the metropolises, and they would be much convenient, they would have much convenience if you go and assist them, you and your team. That way you will be able to create systems for them, you'll be able to give them solutions in time and and work with them so that the things are done with a proper balance. For structured process of buried utility development, maintenance and management, a city-specific subsurface utility vision document needs to be prepared. This is what is something like CDP, City Development Plan. Similarly, city-specific subsurface utility vision document could be prepared by your team for the urban utility in your city. If you are able to do that, you will be able to assist your urban utility in planning, in site investigation, and project operating procedures. And that basically will help in many ways. Your students would know what is to be done. Your client would know what is the vision document and how he can create, so that he does not build something which is wasted just after 1 year. Because there have been instances where people create the utility, then somebody comes and says, this is useless, break this down and make new one. So all those things can be contained. And obviously, who would be knowing it better than the professor or the lecturer sitting in his city? Because he would be able to see the situation and advise accordingly. This vision document could provide the subsurface utility information system, subsurface asset operation and maintenance systems, and finally, asset termination and replacement systems covering the entire life cycle of the subsurface infrastructure of a subject city. This process could be initiated by assessing the specific needs of trenchless techniques for all utility projects. This vision document would also help in identifying the skill gaps in engineers taking the necessary rectification actions. And believe you me, if you have that capability and capacity created in your institution, or you create a team which can help that, you conduct those kind of training, those kind of appraisals, those kind of assistance to the engineers serving the civic utilities of your area. Believe you me, it is going to be a win-win situation for all. Now, I've detailed structure of the a tentative structure of this vision document which can be created. The basic idea is that you can look at these heads, and based on these heads, you can talk to the civic authority people around you. This will help in creating the document. Also, this will help in letting your students know. The first step would be first understand this vision document structure yourself. Once you understood, transfer that knowledge or information to your students or your learners. And once both of you are confident enough, go and talk to the civic authority people that look, this is what is needed. Now, basically, the first thing what you have to understand is the life cycle of a subsurface construction. I gave you 5 phases. Now, basically, what is the life cycle and why are we designing it like that? Needs to be understood. Second is what is your city requirement. Then what are the advantages of subsurface construction, or using trenchless or using conventional cutting or whatever. Then classification of the activities that this methods can be applied. Then comes subsurface investigations, which would comprise of utility, SUE, and pipeline condition assessment. Then comes new installation techniques which can be applied to your city, pipeline rehabilitation techniques and replacement techniques. All these would be first understood, then explained to the engineers that this is what is to be done. I do interact with several of the civic utility engineers, and they do have the lag in understanding in many cases, which needs to be clarified and cleared. And obviously, as a faculty member, as a teacher, you will be in a position to educate them. So, when I'm looking at the city, I need to define that this is my complete city and this is my this area, subsequent area, how am I going to do it? And the probable technology which can be applied, because let's say if I'm doing a cavity creation, that cavity creation, as I explained, could be done by soil, shifting the soil, cutting the soil, or using the jet to create the cavity. Now, each method will have different connotations and limitations. On the basis of those connotations and limitations, the technique is to be selected that this is what is needed. Say, for example, I'm talking about micro-tunneling and pipe jacking. This would require creation of a shaft, and that shaft would be basically used as the entry shaft, and the micro-tunneling shield would be pushed in. Now, when you're pushing the micro-tunneling shield, it requires a strong backing or a bearing wall. Now, this bearing wall means an extensive investment in the entry shaft. But the benefit is that you can have the defined level at which a tunnel can be created. If I use any other method or some other method, that defined levels might be or might not be available. So those things need to be understood and created. Like, let's say if I have to simply lay signal cable lines, I have to lay telecom lines, it will be one operation. But if I have to lay a drainage line, stormwater drainage line, it has to go with critical grade and alignment. And that is where the technology selection has to be done. Once I have selected the technology, the next step would be estimating the cost. Naturally, a broader valuation can be done when we are talking about the city vision document. But subsequently, when we are talking about the main project, in that case, a detailed project estimation, cost estimation needs to be done. Once I've done that, the next step will be develop the feasibility report, develop the DPR, detailed project report, and then create the contract conditions. Once you've done that, the next step would be pre-qualify the agencies who can really render these kind of jobs. Then I go for project planning and management systems that I create. Then comes the equipment. I need to have capable equipment having sufficient strength, sufficient power, and sufficient size, which can be accommodated in the project line. And then we execute the work. So we need to identify and define the equipment. We need to define the manpower. And here comes your students. They could become some of those manpower, and obviously they will find some employment. So it will be a multifarious win-win kind of situation. Then comes specifications. How do you get your things done? So you get the technical specification frozen for a specific project. Then comes scope of work. That is, what is the work which is actually required. Threadbare, everything clearly defined so that there are no confusions, there are no doubts, and there are no anomalies. Subsurface construction is having substantial amount of risk, and those risks need to be avoided. And that avoidance is something which naturally, as a professor, you can guide, you can give directions that this has to be done. So obviously the safety issues, the waste management, all this also come into the picture. Well, you never know the person who's actually working. Does he know how to do it? Has he understood your designs? So you create method statements. Those method statements define that this are the defined steps, and this is how I go ahead. Obviously, there will be relevant codes which have to be, there are codes available in India, globally. So depending on the applicability, the codes have to be addressed, and all these things have to be done by trained professionals, engineers. Then comes project supervision. We can supervise the work if we know the whole business. And obviously, this is what is another proposition which I'm making. Consulting inputs for trenchless project. And in many cases, the user would be requiring inputs so that they can go for a trenchless project. And you can go in for an advisory assistance to them. So obviously, it will be kind of revenue for the institution for which you work, also the revenue for you yourself. Third party inspection is another aspect where people can go and have a third party inspection so that if anything is going wrong, the third party inspector can get it corrected, record, and finally take the structures or the project work ahead. Once the job is concluded, then we create the ABD, as built drawings, because the buried utilities, the drawing is, if not created, will never give you the exact location of the utilities, the exact material of construction, and exact issues which could be faced. So as-built drawing is something which has to be created, and that needs to be done by some professionals who are working in this line. Then comes road cutting permissions, dispute resolution systems, how do you go about it? So all those. Where from do you get the inputs? We have published some books. There are some textbooks. There are some commercial books. They are available. There are other trenchless publications globally, because in India it is we who publish, but internationally there are many publishers. There are many authors. They provide it. We have our inputs. Our website is there. We provide inputs so that our network people can work. We have a large membership base, about 450 or so members are there. So that network can help. We conduct training programs for people who are interested in trenchless technology. And then apart from us, there are many more organizations who conduct trenchless training programs. Then we conduct Nordic shows, Nordic India shows. They are one of the sources. This year we are declaring on 7th of March, there is a Nordic India conference we are holding, and an invite would be reaching you, where in case if any of your colleagues or you yourself would like to deliver some presentation on underground construction or tunneling or any other subsurface construction matters that can be done, creating INDCT chapters, that would be very innovative thing, because this chapter would have the first business to do create the vision document in coordination with the city specific utility. If that is there, you have a good source of revenue also for everybody. So this brings me to the last part of my presentation, and the concluding remarks are like this. Trenchless technologies offer an effective tool for subsurface construction activities. Due to aging infrastructure and explosive demands, nation will need to develop and enhance its trenchless capacities. Trenchless capacity creation enhancement needs to address each type of stakeholder involved in the project delivery chain. Engineering professionals are needed to be cultivated to serve the essential national need. Academic intervention coupled with industrial inputs are the essence of this objective. To initiate the actions at a grassroots level, we need to implement city-specific subsurface vision documents. Engineering institutions need to become a part of the vision document creation process. That could be done through interacting with the local civic agencies or ULBs, urban local bodies, and providing them necessary advisory assistance. Students could be deployed on the projects for the onward development of capabilities in them. For addressing the technical capability gaps, such institutions could work with INDSTT by establishing chapters at the institution level. Remember, the nation needs to develop its internal capacity for successful subsurface construction projects, and vision document would play a vital role, because then we are talking about these documents being created in each city. Everywhere there are in each city, somebody is creating a vision document, and obviously that will give a wholesome solution for the complete underground requirement. INDSTT provides a major platform for such activities and provides necessary knowledge for developing this vision. Underground is future. Let's maximize its potential for our future generation. And that brings me to the end of this presentation. I will share this PPT with Pratibha, and Pratibha will share it with you. Thank you very much for your patient hearing. And I would love to have discussions with all of you. Please start asking questions. You also, I believe, you have to create questions for PARAKH. So I hope you can begin those with me. So let's start.
Sir, I want to ask one question.
Mr. Debojyoti Roy?
Yes. So myself is Dr. Debojyoti Roy. I am the faculty of an engineering college in Durgapur. So my question is that, can you show an animation or any video of how this trenchless construction is carried out?
Oh, I can.
Yeah.
But it will be easy. You can simply write Trenchless Technology on YouTube.
Okay.
You'll find some millions of videos.
Okay.
Okay, just write Trenchless Technology. You'll find that.
Okay.
Right? Horizontal directional drilling, micro tunneling, pipe jacking, auger boring, Many methods. You can also go on my YouTube channel, India City's YouTube channel.
Sir, another question is that nowadays the cables are laid for mobile technology. So is the same as trenchless
Yeah,
construction?
it is.
Is
Yes, it
trenchless
is.
construction? It is.
Yes, but unfortunately, what is happening is that people who are laying these cables are not that educated persons, or their engineering knowledge is suspect. And that basically means that they are running these machines without realizing that they need to go for subsurface utility engineering process. They need to conduct the underground investigation. They need to use the machine properly. See, what is happening is, when I'm talking about those cable laying machines, the process is that there will be a rotary drill, okay, and you are thrusting it. So it, Dr. Saeed, I'll speak with you. So what is happening is, you are thrusting it, and the soil which is being broken or excavated gets pushed back because of the slurry you are pumping in. Now, to cut corners, unfortunately, some of the contractors are using water instead of using bentonite. If you don't use bentonite, the machine will be overloaded, and if it is overloaded, there is a possibility that it can burn down while it's going in. And if that happens, it is a loss, because how do you take it out then?
Okay.
Bringing out that drill rod itself becomes a challenge. And there are numerous mistakes, errors there. These uneducated operators go and damage the water supply lines. And the moment they damage it, the water will be flooding your areas. I don't know in Durgapur have you faced it or not, but I live in Faridabad, and in my location at least 3 times for the smart city construction, the contractors came and damaged the water supply lines.
So are they not using any sensing technology for whether there is any water line on that?
That is what I'm trying to say.
Okay.
See, there are two levels of this sensing. One level is, first you need to conduct a survey. The second level is, while you are drilling, there is a sensor which sends the signal where it is. Okay. Or what is the inclination, what is the rotation, so that you are able to calculate where you have gone. What happens is that these people will kind of cheat the consumer, telling them that, look here, sir, this is my locator. I am locating it like that. But the question is, where are you locating it? You are locating it in a place where you did not conduct any survey. And if you did not conduct any survey, obviously, there are high chances that you can go and damage some structure there. Are you getting my point?
Yes, thank you, sir.
Yes.
Thank you.
Sir, I want to ask one question. I am
Yes,
Dr.
Dr.
Manish
Nigam.
Nigam from Kanpur, UP.
Ji.
So, what are the major challenges faced by our trenchless technology project today?
See, the challenges are numerous. The biggest challenge what we face is less education of people who are literally running these equipment and doing on the work. What we need is educated people in the segment. What is happening currently is that the people who are working, they are basically working by virtue of being operator of any other machine. From there, they just migrated to Trenchless Technology and started working on it. A micro-tunneling machine requires a Master of Technology degree. If somebody is MTech only, then he can run the machine properly. Because he has to calculate many things. He has to know what is the machine axis, what is the tunnel axis, what is happening, is it both of them are matching or not, what is the material he's sending in for kind of lubricating the soil, cutting the soil, is there any problem, and he has to do everything on a real-time basis. But ho raha hai ye, unfortunately, that many of the places, the operators are fly by night. And that is what we need to prevent. And how do we prevent that? We prevent that only if we get the engineers coming and working in these fields. मेरे पास जितने भी इंजीनियरिंग के बच्चे इंटर्नशिप के लिए या इसके लिए आते हैं, they get straight employment in these companies because boys are not there.
Okay, thank you.
जी, Dr. Saeed, बताइए, you are saying something. Please unmute yourself. Dr. Syed Salim, Saeed. तेरे हो सकता है आपसे ऐसे ही हो गया हो. Mr. Suresh, M. Suresh, you wanted to say something? Mr. Gyan Ghosh.
Sir, I have a question.
Yes, Mr. Shinde.
Sir, how will you compare the underground projects as compared with cost and lifespan with the over the ground projects?
Your question is actually pretty large, I would say. See, the thing is, when I'm talking about underground construction, the loading is known to me or unknown to me. Depending on that, I will be creating my structure. If the structure is above ground, I'll be designing it with certain different loading. The loading in underground structure is bound to be higher than what we have above ground. So obviously they have to be little bit more expensive, but then the duty what they perform will also be higher.
Okay, sir. Thank you, sir.
Ji.
Hello, good afternoon, doctor. Good afternoon, sir.
Dr. Afzal, tell me.
This is Dr. Afzal from Chennai. I just wanted to ask you, sir, what about the structure of the soil? Is there any diameter, some diameter to the which you can do it? If you go for a larger diameters, how the structure of the soil is going to change? Because normally in the surface structures will be having the retaining walls for the soil, but
Yeah.
here in the underground we cannot
Hmm.
exactly predict the soil structure when we go
Mm,
paralleling trenches. So
see,
is there
see,
any diameter restriction for that, sir?
that's what I'm telling you. There are two parts of a question. One is the subsurface soil strata quality. Okay. Now the subsurface soil strata quality is evaluated by having boreholes and drawing a GBR, that is ground baseline report. So by that you can possibly find out the quality of soil what you have there. Now comes the diameter part. The
Sir,
diameter,
sorry to disturb you, sir. Up to what depth we can predict it, sir? Maximum depth?
you can that's where I'm going. That's where I'm going.
Yes, sir.
See, what is happening is then that when I'm talking about uh, geotechnical methods to evaluate the soil, we can go for seismic refraction or reflection. We can go for tomography, or we can go for ground penetrating radar evaluation. This can give me depths as deep as maybe thousands of meters. Okay, depending on the kind of radar or the antenna what we are using. Now the depth what we're talking, the restriction what we're talking is that there's only one restriction, and that is you need to retain 2D, whatever is the diameter of your pipe, the surface to the crown of the pipe needs to have a depth of a difference of 2D. Say you're placing a pipe which is 4 meter. If it is a 4 meter pipe, a 4 meter diameter pipe, and you are placing it at a depth of 3 meters or 2 meters, what is going to happen is the the moment you put thrust here, the soil will heave. All right. This heave happens because of a phenomena called Trenchless silo theory. If you search it out, you'll find that. Basically, what happens is that shear strength of that soil slice is unable to withstand this kind of uplift. So to prevent that uplift, what you do is you go below 2D. The moment it is more than 2D, there is no restriction, no issues. There are pipes which are in Delhi. The interceptor sewer is being constructed at a depth of 20 meters. In Numaligarh Siliguri pipeline, micro tunneling was done, which was done from 25 meters to 40 meter depth, because it had to be done for river crossing, and the scour depth of the river was about 22 to 28 meters. So they had to lay below the scour depth of the river. You do the trenchless technology below the rivers so that your river do not damage your pipes. Especially when we are talking about the pipelines, like let's say if we talk about Chennai, in Chennai you have the water collection system, which is a seawater desalination system. you have two pipes which are drawing water from sea coast, and which are being desalinated in Chennai, and then the desalinated like the waste of that is again being pumped out in the in sea. If you find out, you will find that those depths are as long as 4 kilometers, 3 kilometers, something like that, so that your coastal belt is not spoiled. That particular thing is done by a special sea crossing microtunneling method. But again, you have to lay it lower than the scour depth.
Okay, sir. Thank you very much. Thank you very much. One question for the sake of the students. You said
Yes.
the implant training in this is very fruitful.
Yes.
Can you suggest any place in nearby Chennai, sir? Because students coming from here to Faridabad is not maybe possible. Anywhere nearby?
See, I'm not saying in plant. I'm saying on job.
No.
Okay.
Suppose my students wants to come and work with you, something like that, or somewhere a place where you can use this technology.
That's what I'm trying to tell you. Like in Chennai itself, you have L&T executing some of the major metro projects. Okay. That is one. Then you have at least two manufacturers sitting in Chennai. I think one is Trenchless, another is Vermeer, and I think there are three. Herring-Kanish. Yeah, Herring-Kanish. All these are based in Chennai only, or close by. So they can go for exposure there. But see, there's a difference. When we talk about trenchless technology training, it's basically the physical execution. The plant works are some way, the plants are not in India. These equipment are manufactured overseas and imported here. Okay. So if you want to send your students to these plants, then it would be either China or Germany or maybe United States, where these machines are being manufactured. And that is also possible. If your boys and girls are enterprising and would love to go there, but it would entail extreme expenses.
Okay, sir. Okay, sir. Thank you. Thank you. That
Yes,
may not
Dr.
be
Mughal.
possible only for the project work I'm thinking. Okay, sir. Thank
Dr.
you.
Mughal, project work karwaiye, that is good.
वही देख रहा हूँ, वही
See,
देख रहा हूँ.
we need to cultivate capabilities in our students, and
That's what,
we
sir.
need to make them employable. That is the bottom line.
Yes, sir. Thank you very much, sir. Thank you.
Yes. Please interact.
Professor Swarup Tyagi this side from Thapa
Yes,
Institute of
Dr.
Engineering
Tyagi.
Technology, Patiala.
Ji.
Thank you very much for your presentation. Even my background is electronics and communication, but I have enjoyed your session a lot. Thank you so much, sir.
Most welcome, sir. Dr. Tyagi, believe you me, some of your students would find good employment in this sector.
Yes, sir. I will
Because,
share your PPTs with my colleagues in civil engineering department
yes.
so that they can take the benefit.
I'll give you one of the most pertinent usage of your usage of this thing for your students. You see, a standard process of pipeline condition assessment employed is to run a CCTV camera. It's mounted on a robo, and that is put inside the manhole. It simply drives through. It's put on a tractor, so that tractor drives through, and manhole to manhole the video is taken. Okay. Now this video camera moves at a speed of 20 feet per second. So what happens is that let's say a city like Chennai, city like Delhi, where you have thousands and thousands kilometers of pipeline and divided by 20 feet per second. So imagine the quantum of the video what you would have. And then what this video does or what this camera does, it will move on, and wherever there's a crack, there's any damage or anything, it will record it. Okay, so somebody has to see and find it out. Earlier, this job used to be done completely manual. It was manual job, and people used to simply sit on the laptop or computer and sleep. Because what do you see? You simply see a hole in which some light is moving, and you would possibly miss it. Now, boys and girls are creating various softwares for transferring this data into like a readable information. And the moment you run that software or run these videos through that software, you come up with a damage assessment report immediately, instantly. Now, currently, these things are being done in Europe and maybe in America, but I have no doubt that my own boys and girls have the capability to develop these kind of systems.
Yes, sir. In future, we'll try to connect you, and we are having number of PhD students over there, and I will try to discuss the things with them also, so that we can utilize the things in future. Thank you so much, sir. Thank you so much again.
Most welcome, sir. आप लोगों से it is expected that all of you would be creating questions and submitting it to AICTE or submitting it to CIDC for onward submission to AICTE. So I hope you are able to create some questions, or some questions could have come to your mind. In case if you need any assistance from me, do communicate with me. You'll get my contact details on this presentation. So I think there are no more comments. Should we close it?
I think, sir, there is no questions. Thank you, sir, for your valuable time and sharing your knowledge. With your permission of you, sir, could I close the session?
Yes, please. I'll be sharing the presentation with you, and you can in turn transfer it to everybody.
Okay, sir.
Yeah.
Thank you, sir.
Thank you, sir. Thank you very much.
Thank you, sir.